Welcome to clickmyproject.com. Let's discuss on the title Image Contrast Enhancement and Noise Reduction using Local Tone Mapping. In this paper, we propose a noise reduction method and an adaptive contrast enhancement for local tone mapping. After initial compression of the luminescence of HDR image, the proposed local TM algorithm decomposes an initial compressed luminescence into multi-scale subbands using the discrete wavelet transform. The decomposed subbands are filtered using a bilateral filter and soft thresholding, and then the local contrast is enhanced by an adaptive weight, which is derived from the luminescence compression function with the color constraint. Finally, the color of the tone mapped image is reproduced using an adaptive saturation control parameter. In above experiments, the tone mapped color image of the proposed local TM algorithm is compared with those of the conventional TM algorithms with post-processing. Computer simulations with noisy HDR images shows an effectiveness of proposed local TM algorithm in terms of visual quality as well as local contrast and detail preservation. Here we extend this paper by implementing the same algorithm to videos where a low resolution video is being converted to high dynamic range video. Regarding the DFD, you have to consider input multiple exposures, that is, you have to feed a frame which have multiple exposures as an input. With that, you have to construct an HDR sequence. This HDR sequence will be holding a high dynamic range frame values that cannot be viewed on a low dynamic range devices. Such an HDR image must be subjected to luminescence compression. Here you will be having a color conversion, that is from RGB to HSV or UV, any color space having the luminescence value. That particular luminescence value alone will be compressed and it will be subjected to decomposition. In decomposition, we implement 2D discrete wavelet transform using Haar filter. So this will be providing you with 4 bands, LL, LH, HL and HH, that is low frequency bands, high frequency band, diagonal band and vertical band. So apart from low frequency band, the remaining 3 bands will be subjected to a denoising filter based upon subband thresholding. After that, the output will be given to contrast enhancement. Here the frame contrast enhancement will be concentrated and it will be fed to color reproduction, where saturation plays the important role. So this may be implemented for the entire video sequence that is got from the low dynamic range images. Now let's have the execution of the program. Regarding the execution of the program, you have to select main tone mapping.m file and press run file. This is the guide designed for viewing the execution of the algorithms. Have to select a video. I'm selecting video 2, which comprises of multiple exposure of a single place. Convert that into frames. These are the frame conversion: low exposure, mid exposure and high exposure. Now add noise to the video content. This is a noisy video sequence, and now convert it to an HDR video. This may take some time. HDR video sequence will comprises of multi-exposure frames, and following that you have to do luminescence compression and adaptive tone mapping. In adaptive tone mapping, you will be doing 2 steps, both denoising, the same time color reproduction. So this is the HDR video. Now perform luminescence compression. The luminescence compression will be done by changing the color space value, and this is the HDR log luminescence output. And now will be the adaptive tone mapping. This adaptive tone mapping may take some time. This is the denoised output, the denoised frame, and this is the adaptive tone mapped output. Now we will be seeing the analysis. For analysis, click the button called as analysis. We will be getting a graphical analysis and a table that is representing a low exposure and tone mapped low exposure frame, mid exposure and tone mapped mid exposure, high exposure and tone mapped high exposure frames. So when you click this analysis button, the values will be computed. This is the IQI graph, this is the SSIM graph, PSNR graph, SSIM graph and MSE graph. These are the values representing those appropriate graphs. So this paper has proposed a noise reduction method and an adaptive contrast enhancement for local tone mapping. The proposed local tone mapping algorithm consists of initial luminescence compression, image decomposition, noise reduction, local contrast enhancement, image synthesis, and color reproduction. Here the image decomposition and synthesis is carried as a frame decomposition and synthesis, and for that we use discrete Haar wavelet transform. The decomposed multi-resolution subbands are filtered using bilateral filter and soft thresholding for reducing coarse grain noise, and then the local contrast is enhanced by an adaptive weight which is derived from the luminescence compression function with the color constraint. Finally, the color of the tone mapped image is reproduced using an adaptive saturation control parameter. Noise reduction and color reproduction methods can be combined with other TM algorithms for noise or false color suppression. The tone mapped image. Here the video of the proposed local TM algorithm gives better image quality than those of the conventional TM algorithms. Thank you.